Okay, greetings. Good evening, everybody. Chris from Practical Navigator. We're going to talk tonight about Starfinder problems. So what I mean with Starfinder is this guy right here. It's from Weems and Plath. It's a Starfinder. It's got all kinds of good stuff inside of it. And we're going to use it to either identify a star that we see and we're not sure what it is, or select some stars that we can use to navigate by. Right? And there's just a couple of little things we need to learn about before we use the Starfinder. But let's take a look at it and just see what kind of stuff we have to deal with. So if we look at this Starfinder here, we open it up. Inside of it, we're going to find some instructions. This is a pretty old one. So some instructions. There's a bunch of these plastic plates, these little plates. And these plates all correspond to different latitudes. So it's hard to see with the lights, but this is a latitude of 25 degrees north for this one here. And there's different latitudes for each one. There's one for planets, all these different plastic ones. And then a base. This base comes in northern hemisphere and southern hemisphere. And in essence, we need to choose a plate, choose a hemisphere, and spin this thing. And we're going to eventually get a look at what stars are directly overhead or out at the horizon or various places in between. So this tool requires a couple inputs before we can use it. All right. So the first thing to mention is a little concept. It's called LHA. We haven't really talked about that in the evening broadcasts in this little semester that we have going, but we're going to talk about it right now. If this is the Earth, spherical Earth, and there's Greenwich in the UK, that's going to be the 0 point for longitude. Right? The 0 point for longitude, where longitude begins. Up in space, there's a star, the sun, the moon, the planets, whatever. If you were to drop a line right down onto the Earth from it, you would have what's called the geographic position, or the GP. If you were standing at the GP and you looked straight up, the star or the planet or the sun would be right above you. All right, and what we're going to do is just kind of relate some different longitudes here to each other so that we know the terminology. All right, so the GP, the spot on Earth directly beneath the star, that has a longitude as well. And that longitude is called Greenwich Hour Angle, GHA. So it's the distance from Greenwich. Just the distance west from Greenwich. It's always west. That's a little different than you might have seen on other problems, right? There's no eastern or western hemisphere when it comes to this. It's always west of Greenwich. And there's another spot out here that we need to know about. That's where our ship is. Our ship is, say, out there. This distance here is called our longitude, and that's the symbol for longitude, lambda. Right? So we've got a longitude as well, wherever our ship happens to be. Okay, so that's just longitude. We have a longitude, the star has a longitude, the sun has a longitude, etc. Right? So they've all got different longitudes. It's just called different things. It's called GHA when we're talking about stars. There's one last angle to talk about, though, and that's the difference here between us and the star's longitude. That's going to be called local hour angle. Local hour angle. So these are related in that Greenwich hour angle minus my longitude is going to be equal to local hour angle, LHA. Right? It's a little different in the Eastern Hemisphere. I know I just mentioned that GHA is 360, but if your ship is located over here, it's slightly different formula. But for us and for the problems we're going to do tonight, they're both in the Western Hemisphere. So GHA is the longitude of the star or the sun or the moon. Longitude is your longitude, and LHA is the difference between them from your ship to the star. All right. So hello to a few folks joining there, some regulars. Sailor John, glad the books made it. Happy to see that. Eagle River, Alaska is pretty far, so all good. All right, so LHA is one concept we need to know when we're using the Starfinder. The other thing that we need to know is we're actually not going to use a star to set up this equation, we're going to use what's called the first point of Aries. Aries is a constellation up in the sky, and the first point of Aries is the point in the sky. It's actually just it's not really that visible or very apparent or anything, but it's the point in the sky that crosses over London's longitude on the spring equinox or the vernal equinox. None of this is important to use the Starfinder. It's just background information. So on the vernal equinox, the first point of Aries passes over London's longitude. And it is, in essence, the first point of Aries is the Greenwich of the sky, right? It's just a 0 point for the sky. And that's what we use to orient things up in the sky, the celestial sphere. So if we want to use the Starfinder, what we do is we calculate the LHA of Aries. And that allows us to set up this device in such a way that we can accurately represent where we are in the sky. Right? So when we set this up, the middle is going to be right overhead. The edge is going to be the horizon. So we need to spin it around to accurately represent what's going on for us. And the only input that we need is the LHA of Aries. So these problems are actually not too bad. The challenges you have are, one, getting a hold of a Starfinder to practice with, because they have some cost to them. But if you're studying for a Coast Guard exam, they're located in the testing room, so you'll have access to it. So it's worth studying a little bit, or maybe even just using these videos to help get yourself set up if you're studying for the test. But otherwise, we just have to calculate the LHA of Aries. So let's get cracking on that. If you look down in the video description, there's a couple of problems that we're going to work on tonight. And we'll do the first one, which begins on 17 March. So just give me a moment to set up the board here, and we'll get rolling. And on your test, there's only two types of problems you can see. So one is star identification. This is the first problem we're going to do. And the second one is star selection for navigation problems. Okay, Miss Neelam, thanks. Welcome there. Good spelling. So good. All right, so the first problem states that on 17 March, we're out there navigating around, and at 1845, our position, our dead reckoning position, our approximate position, is 2510 north, and the longitude is 6648 west. So that's where we think our ship is, and it's maybe like a partly cloudy night, and I see a star up there, and I need to identify it because I can't see the other constellations around for whatever reason. So let's say that we see an unidentified star bearing 320 degrees true, and it's at an elevation of 50 degrees, 02.9. So I look through my sextant, and I look up in the sky, and I see this star. It's a bright star. It's apparent. It's clearly a navigational star, but I don't know what it is because I can't relate it to the constellations around it. I look at a bearing of 320. That's a direction, and a height or an altitude of 50 degrees. The other piece of information that the problem gives us is that the chronometer, when we took the site, read 10:47:49. And we know, for whatever reason, that the chronometer is fast. It's 1 minute and 54 seconds fast. So if you've done a session with me on chronometer and ETA problems, either way back on the live stream or on a couple of other things we've got going on, you'll recognize that the Coast Guard often throws these little chronometer issues at you in the beginning of a problem so that you can, have to work to get your answer. I guess that's what they're looking for. So if the chronometer says 10:47:49 and we know it's fast, we need to get that back to GMT, get the actual time of the site. So if the chronometer is fast, do we need to add or subtract that 154? Right? So the answer is we have to subtract the 154. Adding and subtracting time is a challenging thing to do, right? So if we take 49 seconds add 60 to it, and subtract 54, we're going to get a time of 55 seconds, and we're going to get 45 minutes and 10 hours. Right? That's not necessarily GMT yet. Not necessarily GMT yet. It's our chronometer time. But we're going to look for the GMT. That's our goal. All right, so 10:45 is the corrected chronometer. Sorry, I wrote that in the wrong spot. We're going to look for GMT. Now, our dead reckoning longitude is 6648 west. So what does that mean for us? How important is that? Well, if this is the 0 point for longitude, that's GMT, each time zone is going to be 15 degrees. 360 degrees divided by 24 hours is 15 degrees per time zone. And they correspond like this: plus 15, 30, 45, and 60. This is going to be plus 1 hour, plus 2, plus 3, plus 4. So if we're here, that's the closest one, we're at 66. We're observing this time zone of plus 4. So we need to take whatever's on our watch or whatever's on our chronometer, right, and advance it to Greenwich Mean Time, for sure. Okay, so what we're going to want to do is we'll take the chronometer site, and we'll just simply add 4 hours to it. Right, 4 hours. So this is our chronometer time, 10:45, and we'll add the 4 hours to it, and we'll get 14, 45, 55 seconds. That's the GMT time that we need there. All right, so that's one of the skills that we're going to need to use the Starfinder. It's just the ability to work on chronometers in order to, get where we're going based on our DR position, understanding our longitudes here, making sure that we end up at the correct time when we're doing all this stuff. All right. So let's say that we've done this step of the problem, and we're going to focus on the next step of these kinds of problems that happen, right? And that's going to be determining the GHA of Aries and the LHA of Aries so that we can use the Starfinder. So I'm just going to erase all this stuff. And we're going to need the nautical almanac for this next thing. Yep, you're right. You're right, Sailor John. John, that's where the chronometer uses clock time, and your local watch and clock use clock time, and the GMT is always in 24-hour time. Exactly. So let's think of a different example for the next phase of our problem here. Let's say that we've got a GMT. I'll be honest with you, I messed up some kind of math here along the way, but whatever, we'll roll with it. Let's say our GMT is 22 hours, 45, and 55. I'll track down the error later unless somebody wants to point it out, but it might be what you're saying there, John. Something in my notes went awry. But if this is the time of our site, we need to look into the nautical almanac to determine the GHA of Aries. And if you recall, that's just the longitude of Aries. So what we can do is go to the nautical almanac for that one. I don't know how this is going to come out in the live stream, so I apologize if it's not very clear, but here's the nautical almanac. Right? And in the daily pages of the nautical almanac, over on the left-hand side, it's going to give you a column for Aries. Right over here, Aries. So I'll try and zoom in here. So there's Aries. And here's the 17th of March, on the Tuesday, the 17th of March. So if we're looking for a time of the site of 22:45:55, we're going to go down to 22, and we see that the GHA of Aries is 1:45:23.1. Right, 1:45:23.1. And if it's not super clear in the live stream, usually it gets better if you're watching this in the future. But 1:45:23.1. You'll notice our time of 22:45 is not listed. Just 22 and 23 is. So we're going to need to use the nautical almanac to help figure out that little gap. And if you go to the back of the nautical almanac, way back here, there's these increments and corrections pages. So if we get to a page for 45 minutes, here's a page for 45 minutes and 55 seconds. We can look way down here at 55 seconds. There's a correction to be made of 11 degrees, and over here 55, 11 degrees 28.8 minutes. This one right there. Right, so we were at 45 minutes, come down to 55 seconds. There's the correction for the sun and the planets. Next to it is the correction for Aries. All right, so next to it is the picture for Aries. John, thanks for the feedback. That's good to know. Trying something new tonight. The experiment in live streaming. All right, so this is the correction for Aries. There's also a correction for the moon. If we ever needed that, there's the correction for the moon. So we want the one from Aries. So anyway, the correction is 11:30:06. Right there, 11:30:06. Yep, it's always going to be an addition as well. It's always added. Thanks for the comment there. Can't remember what it was. 11:30:06. 30.6. That's our correction. So why do we need a correction? Well, this is for the whole hours. This is for the increments, the little bit that we haven't accounted for yet. Right? So we need to add these together. So 0.735156 degrees and 53.7 minutes is the true GHA of Aries. Okay, Ian, good question. I'm not going to get to the planets tonight. We can do that in the future, but it would be a pretty long broadcast if we're going to do that. But I can talk a little bit about the planets as well. That's no problem. And I can also point you to a great link on the planet stuff if you're looking for that. So we're going to just focus on stars tonight. But thank you for the question. So there's the GHA of Aries. We've got the GHA of Aries, which is great. That's kind of like step 1 of 2 for this whole thing. What we actually want is the LHA of Aries. Right, and so earlier we kind of talked about our ship being out here, and that little distance is LHA. And the formula that we needed was GHA. LHA is equal to GHA minus longitude in the Western Hemisphere. It's different in the Eastern Hemisphere, but all good, right, for this one. All right, so if we take the GHA, 156.53.7, and we subtract our longitude, which I erased off the board, sorry, but let's see. It should be listed in the problem there. 66.48 was our longitude, right? We're going to get the LHA of Aries. All right, so 53.7 minus 48 gives us 05.7 minutes. And then 156 minus 66 gives us 90. So our LHA of Aries is 90 degrees 05.7. Here's the nice part about these for Coast Guard test purposes. And if you're just using the Starfinder, none of that matters. Like it's more of a guideline because you just need to spin that thing to approximately the right setting. So even if you just estimated this, you're going to be just fine, right? So that's the nice part about the Starfinder problems is the precision level is required is very minimal. So let's take a look back at the Starfinder and how we actually are going to use it. Click back over here. And we should be looking at the Starfinder again. Little light issue there. Okay, so the first thing to do is pick the hemisphere that we are in. So this is the one for the southern hemisphere. This is the one for the northern hemisphere. So that's the one that we want for sure. So we're going to use the northern hemisphere. So that's good. The next thing we're going to do is pick the plate that has our latitude on it. So our latitude in the problem was 25 degrees and 10 minutes. So here's one for 85 degrees north. That's not it. Throw that down. Here's the planet ones. I'll save that so we can talk about that later with Ian. And then 12 and a half, you know, here's a bunch of different ones. Here's 25. So you're going to see, if it comes out in the picture, there's latitude 25 south. And then if you flip it over, there's latitude 25 north. Right, so we want the one for latitude 25 north. So north on the plate, and north on the card. You put the pin in there and you just spin it around until you get to the LHA of Aries. So ours was 90. So I'm going to spin this until we get to an LHA of 90, which is right there. Tilt it a little bit. And then we'll zoom in. So here's the LHA of Aries over here. Just spin it to 90, and you can see the accuracy does not matter really one bit at all. So I'm just going to rotate this for illustrative purposes. What we're looking at here is a representation of your night sky in your position. So right in the middle is going to be directly overhead. So it looks to me like the star Elnath is directly overhead in our case. All right. And then this out here is the horizon. So if there's any stars that are outside of this area, then they are not visible, right? So they're just below the horizon in your case. So here's your zenith, or the spot directly over your head. Here's the horizon. And then you'll notice it's a little challenging to see. I'll zoom back in again here. This is your elevation. 70 degrees, 60 degrees, 50 degrees, 40 elevation. So you go from 90 down to 0 elevation. Right? So the problem said that we saw a star at an elevation of 50 degrees. So the star that we saw is somewhere on this ring. So it looks like the star Procyon is close. Alnilam, which is in Betelgeuse, is close. Mirfak is close. Menkar is close. So it's probably going to be one of those in there. The other thing that's important about the Starfinder is here's your bearings, right? So 10 degree bearing, 20, 30, over to 320. That's the one the problem said. So you go from the middle out to your bearing, and we see that at a bearing of 320 at an elevation of 50, the star Mirfak is right there. So I can't say that I've ever actually used that one in a site myself, but there it is, right? So there's star Mirfak. So this unidentified star that we saw in the sky is going to be Mirfak, and that's going to be your answer. So you can use this in real life for sure to identify stars that you're not aware of. We have computer programs that do that now, obviously, so you can do that as well. But the Rude Starfinder is a legit device that you can definitely use. Okay, so let's take a look at another problem here. And this is going to be a different one. This is about star selection. Star selection. All the same principles apply, right? We just need to choose some stars for observation later in the night. So first, a little diversion. What makes a good star to choose? Right, if you're out there on your boat, floating along, splendidly isolated, what makes a good star to shoot? Well, if it's too low, there's going to be a lot of atmospheric refraction. It does not make a good sight. You have to do some additional work with your correction. If it's too high, it's hard to look at, right? It's just simply hard to take a sight of. You take out the famous flame sextant, right? If I'm taking a sight way up there, it's very challenging for me to get it all the way down to the horizon. Right? So we don't want anything that's too high, and we don't want anything that's too low. So it needs to be somewhere in like the 30 degree to the 60 degree range, optimally in there, right? Could be higher, could be lower, but definitely not too high, not too low. The other thing is, if you think about your boat from above, now we're looking down from the sky. When you plot these lines of position from different stars, you want them kind of spread out throughout the sky, right? That would be good. We get one line of position from that one from this one, and one from this. So you get a nice spread of the stars. And usually like 60 degree spread horizontally is good, right? If you ever had two stars that were exactly opposite in the sky, like this one and this one, we've got a spread of 180 degrees, but the lines of position are in essence the same. They're just opposites. So they're not really going to help us when we try to navigate. So we want three objects that are spread by around 60 degrees, not too high, not too low. That will make a good sighting for us. Okay, so let's take a look at the second problem, which is in the notes below this video here on YouTube. And it talks about 28 February. And we're at 1850 zone time position. Our dead reckoning is 2749 north and 159.24 west. Which of the following stars is going to be most suitable for our star selection, right? And it gives you 4 choices of 3 stars each. Like, that's a lot of stars. You don't need to know them. We just need to kind of figure out what's going on with our position and what's up in the sky, and we can infer which ones are good and which ones are bad. So at 1850, they don't tell us we're moving. They don't tell us what star time is, so we're just going to go for it at 1850. So we need to turn 1850 into GMT. And if our longitude is 159.24, what time zone are we observing? We're going to be observing a zone of plus 11. Right? The way I did it is I took 159 divided by 15, and that gives me 10.6. It tells me I'm closest to my 11 time zone. Right? So if I take that 1850 and I add 11 hours and then subtract the day, I end up at, what was it, 0550 on 1 March, right? 28th of February. We're turning this into GMT. We're 11 hours back on GMT, so we're going to turn that into GMT, and this is going to be the time of observation. This is a core skill for this type of problem. It's not what I want to focus on tonight, but suffice to say that's what we're looking for. So we need to get the GHA of Aries. So to do that, we're going to refer to the nautical almanac. And our date was 1 March, right? All right, so we'll flip over to the nautical almanac here. And we're looking for 1 March. So over here is all the sun and the moon stuff. So we're going to shift over to the port side here, or the left side, and we've got Aries. So the 27th, 28th, the 1st of March. If I look at 0500, the GHA of Aries is 233 degrees and 54.9 minutes. Just zoom in real quick so you can see that. Right, 0500. We don't have our exact time, 0550. And like I said, if you just chose the closest hour, you're probably going to get fine on your exam. So save some time when you can. But 233, 54.9. That's the GHA of Aries. Right, now to account for the kind of leftover minutes there, we have to go back to the increments and corrections pages, which is the yellow ones, for a time of 50 minutes. 50 minutes. So here's 50 minutes. And here's the sun, the planets, here's the moon, here's Aries, right? And so it doesn't talk about any type of seconds. So we're just going to look at 50 minutes and 0 seconds. So the correction is 12 degrees, 32.1. And it's always added. You're exactly right there. Yep. So 1232.1 is our correction. That correction just accounts for this 50 minutes left over. All right. So we can add this all up. 4.9 plus is 87, 27.0. And the 233 plus 12 is 246 degrees. So this is the GHA of Aries, calculated for the exact time, 0550. Cool. We want the LHA of Aries, so we gotta do that. LHA of Aries. It's just going to be GHA minus longitude. So our longitude is 159 and 24 minutes. So that math I can do without embarrassing myself. We'll say it's 03 minutes. And, sorry, maybe I can't. 246 minus 159. Gives us 87 degrees. So 87 degrees in 3 minutes. Again, how accurate do we need to be? Not very accurate, I would say. Okay. So once we have the LHA of Aries, then we can go into the Starfinder, spin it around, and take a look at the stars. Very important. Remember, we want them, kind of in the middle of the sky and spread out horizontally. So take a look at the answers in the video description below, and we're going to go through them all systematically and say why they're good or why they're not good. We'll shift back over to the Starfinder. And first, are we in the northern or the southern hemisphere? Well, our latitude was in the northern hemisphere, so that's the plate that we want. Just remember, the other side is the southern hemisphere. So that's good. And what was our latitude? Our DR latitude was 2749. So we want to choose the closest plate to that, which is 25. We want to set it to 25 north, rather than spinning it to 25 south. So 25 north, put it in there. And then off we go on our little adventure. So the LHA of Aries was 8703. So we need to spin this over to 87. It's actually pretty similar to the last problem. And then I'll just orient this for us so we can see it a little better. Okay, and so as an example here, the star Elnath is directly overhead. This is our horizon out here. So all of these stars are below the horizon, so they're not useful. So let's look at the answers. And these type of problems on your exam, you're always going to need to eliminate the other 3 choices you've got there. Where can you get a Starfinder? I think anywhere you can get like Weems and Plath stuff. I use Maryland Nautical for a lot of my supplies, or Starpath School of Navigation out on the West Coast. But this is a great device to have. It's also a great device to borrow, to be honest, so you don't have to keep it yourself. But let's look at the different choices that are available here. And we'll start, you see the right answer because I gave it to you, but let's look at choice D first. Bellatrix, Vega, and Regulus. Is that going to make us a good fix? Well, Bellatrix is right here. So that's pretty high in the sky. Not the worst, but not the best either. 70 degrees high in the sky. That's not too good. Vega, where's Vega? Vega is out here. So that's below the horizon. So clearly this choice is out already. But where is Regulus? Regulus is right here. So that makes a pretty good star. It's at the right elevation. And that's going to be a good star to navigate with. But the other 2 are not. So choice D is out. How about choice C? Hamal, Alkaid, and Canopus. By the way, I call Canopus Canopus because it sounds cooler, but you can call it whatever you want. I think the appropriate name is Canopus. So Hamal, Alkaid, and Canopus. Here's Canopus right there. It's pretty low in the horizon. Not the worst, but not the best. It's 10 degrees above. What else do we have? Hamal is there. That's a good one. That's a pretty good one. So we're not out of the woods yet. And then Alkaid is right there. There's Alkaid. So that's low on the horizon as well. So choice C is not necessarily completely out, but two of the stars are pretty crappy, so we want to skip that. Let's look at choice B, Sirius, Mirfak, and Elnath. Well, we found Elnath earlier. That's right overhead. That's not going to be very useful for us when we're navigating. It's not going to give us a good line of position. So I'm guessing that one's out, but we'll find the other ones. Sirius is the brightest star in the sky, and there it is. That's a really good one, actually. Between 40 and 50 elevation. That's a great star to look at. And the other one is Mirfak. Oh, that looks good too. That's at 52 degrees, so it's between 50 and 60. So these are at great elevation. Here's the problem. They're exactly opposite of each other, or pretty much exactly opposite. So this one's on a bearing of 320, and this one's on a bearing of 160. So they're spread out, but they're too spread out. If you got lines of position from each of those, they're going to really cross and not be useful to you as a navigational aid. So that's a tricky answer. Two good stars, but they just happen to be opposite of each other. So let's keep choice B as our winner so far, unless we get a better one with choice A. Rigel, Schedar, and Regulus. So Regulus was here. That's a perfect one. It's 30 degrees above the horizon. What else do we get? Schedar is right there. 25 to 30 degrees, so that's good. A little low, but pretty good. Schedar. And the last one was Rigel. Rigel is right there. 55 degrees above the horizon. So they're spread out, right? None of them are opposite of each other. They're all going to make good individual LOPs, and they're spread out. So that's going to be the best choice for us, choice A. So choosing between all of these, you got to go by process of elimination and get rid of the ones that don't make sense, and then choose the one that does or makes the least worst sense, if that makes sense. Okay, so you're going to see two types of questions on your Coast Guard exam in the US if you're taking it there. One is going to be star identification, which is the first problem we did. Two is going to be the star selection, choosing 3 stars or planets to help you make your fixes. So the steps were to get the right time for the site, figure out the GHA or the longitude of Aries, Aries being the first point of Aries, which is the 0 point for the celestial longitude sphere. It's the point that crosses over London's meridian, the 0 meridian on the vernal equinox. Neither here nor there, just trivia. So get the GHA of Aries, calculate the LHA of Aries, which is GHA minus your longitude to a reasonable level of accuracy, and then spin your star tool, your Starfinder, to that LHA and make your choice from there. Okay, so I'll leave it there for now. That's kind of all I wanted to cover, but I will talk about planets real quick, if you give me just a moment to get my notes on that. So the deal with planets is you need to use, so the Greek word for planet is wanderer, right? And because if there's stars up there in the night sky, if you look from night to night, the planet tonight might be there, tomorrow it might be here, and they're gonna sometimes trace these weird patterns in the sky, like Mars does retrograde motion, which is kind of cool. So the planets are not fixed, and so therefore I can't use this plate because this plate is fixed. The stars are part of the fixed celestial sphere, and although you see different stars at different times of the year, they stay fixed relative to each other on human life scales. There is this plate, which I'll show in a close-up in a second, is 4 planets. And so the general idea, I'm not going to work a problem if that's okay, but I'll show you the general idea behind it, is you set the planet plate onto your Starfinder. You go through the normal steps, and you figure out if you're in the northern hemisphere or the southern hemisphere. So you use the right plate, and then you put the planet plate on there. And what you do is you go through the nautical almanac. All right, so here's an example of the nautical almanac for like Venus, Mars, Jupiter, Saturn. There's GHAs and declinations for all of these. And as Ian says, RA, which is right ascension, is pretty much the same as GHA for navigational purposes. And declination is just declination. So if you can find the coordinates of the planet, and we'll come back over here to the whiteboard for just a sec. If you find the coordinates of the planet using the nautical almanac, on our Earth, there's the UK, the planet is up there. It's going to have some spot on the Earth that's directly beneath it. It's going to have a GHA, or a right ascension, and it's going to have a declination, or a latitude. So that spot is something that we can plot onto the Starfinder. So depending on the season, what we'll do is we'll look up the GHA and the right ascension, or the declination, the GHA or right ascension and declination of the body. We'll go through those same correction steps for the time, right? If it's not exactly, say, 900, if it's somewhere in between, we have to make some corrections. And then what we end up doing is using this tool to plot the altitude, right? The position of it. We can spin this around to get to the right spot, and say we found out that this star had a 10-degree declination. We spin it to the right GHA. We can draw Venus right on our Starfinder, and then it's as if it's part of the fixed celestial sphere. So there's Venus just for tonight. Then you go and you take your 25-degree plate for the northern hemisphere, you spin it to the appropriate LHA of Aries, and you can see if Venus is going to be good for your observation or not. In this case, it would be. It's perfectly elevated and stuff, and you go from there. The problem is you have to do this, I wouldn't say necessarily every night, but pretty regularly, using this red plate to plot the declination and the GHA of these planets. So depending on what you want to use, you can plot it that way, and then just use the Starfinder like normal. So calculating the LHA of Aries. So it's more of a step. There are a couple of Coast Guard problems that deal with planets in them. So if you're interested in that, I think the link to the Cutterman's Guide to Navigation Problems, which is my little textbook thing, is either in the video description or maybe like last week's video description if I haven't put it there already. And then you can download that whole chapter if you want for free, and take a look at the planet problems in more detail. Okay, so I'll stick around for a few minutes if there's any questions, but just wanted to say thanks for watching. Hopefully you got something out of this Starfinder lesson, and happy navigating. Okay, you're welcome, Alex. Thanks. Alrighty, Paul, thanks for watching. Appreciate it. Okay, this is Chris signing off. I'll stick around the chat for a little bit if you've got any questions. And I hope you have a good night. Goodbye.